folks. So a few definitions based on everything that we just talked about in that previous video. So electrochemical cell converts chemical energy into electrical work or electrical work into chemical energy. So it could be reversed. Okay. So a voltaic cell is chemical energy transformed into electrical energy by a spontaneous redox reaction. This is a battery. And so I did a bad job here. I didn't give you a definition of electrolytic cell. So I'm just going to write that down here. And we'll say an electrolytic cell, well, I'm going to show you a picture of one soon, is the opposite of a voltaic cell. So if a voltaic cell has a spontaneous reaction, in an electrolytic cell, there's a non-spontaneous reaction. So if in a voltaic cell, it's chemical energy transformed into electrical energy, an electrical cell is electrical energy transformed into chemical energy. Okay? So a cell diagram is symbols that show how the components of an electrochemical cell are connected, and we'll learn how to write a cell diagram. So anode, that's the half where oxidation takes place. Cathode, that's our reduction half. And salt bridge, or even the porous bridge, which those things are different. A salt bridge and a porous bridge are the same thing, but they serve the same function. It's a bridge that connects the two solutions and balances the flow of charges and allows you to have this complete circuit in your electrochemical cell. Okay, so here are two pictures, and right here, this top or this left one is a voltaic cell, and we can always tell when something's a voltaic cell because it is providing a load or energy to do a task, such as light up a light bulb or charge a cell phone or something like that. Okay. So this is our electrolytic cell. And you notice the main difference, for one, the positions of the cathode and anode are switched, and also we have to supply energy to the electrolytic cell. So in a lot of ways, when you think about our rechargeable batteries, they are both voltaic and electrolytic cells. They are both, right? They have a really high-tech switch that allows you to switch the flow of electrons. And in one position, it operates as a voltaic cell. It gives you power, right? But in another operation, you have to give it power. So in other words, you've got to charge it up, okay? So, and in that, you'll notice here that everything kind of switches around depending on which way our electrons are flowing, okay? So we still have electrons flowing from anode to cathode in the electrolytic cell, right? And electrons flow from anode to cathode in the voltaic cell. However, just their positions are switched relative to whether we're using power, we're getting power out of the cell, or we're charging it up. We're providing power to it, okay? So this is spontaneous, thermodynamically spontaneous. So we could conclude this is right at delta G less than 0. This is non-spontaneous, a delta G greater than 0. And that makes good sense, right? If this is spontaneous, it is going to give us free energy. And we can use that free energy to do a number of tasks, okay? And this non-spontaneous cell, we have to supply it with energy, which means you got to plug it in and charge up your battery, okay?